Hello, my name is Vicky Lau. I am a compositor here at Magnopus and colleague of Alex Henning, and today we'll be covering the stitching process in Nuke and how to integrate what you found and the values in PTGUI into Nuke. Alright, so right here we have a fresh comp. And actually, let's set this up for VR, and we're gonna press S in order to bring up the Properties tab settings of the project, and then change this to the project or the footages frames per second, and I believe that is 59.94. Now let's also change our frame range to 1001, and let's say 10,000. And I'll explain this later why you need to do this, but at this point simply do this so that our frames will all be matched. And it's 59.94, and there you go. Alright, so now actually let's create an SD map. And I'm assuming that if you got into this point that you have already created an SD map and brought it into PTGUI to create the TIFF files of the undistorted SD map as well as the center hero camera fisheye image. So, but very quickly though, let's actually create an SD map. First thing you want to do is create a reformat node, and basically this node, you have to set the output format to the resolution size of your GoPro camera. So we don't have one here, so let's actually create one right now. Let's call this GoPro resolution and set the width to 1920 by 1440, and that will actually create your resolution size of the GoPro camera, as you can see. Now let's actually create a ramp. And this one here, we're going to set this to red channel. And just so you know how this works, the 0.0 and 0.1 is the correlation on the canvas right here in terms of how much gradients you want to set. So because we're doing this for the resolution size of the GoPro camera, we're going to have to set this at the x-axis as 1920. And then creating another ramp with just the green channel and setting this up as 1440. Now, as you can see, this is your quick ramp right here. However, when you brought it into PTGUI, you might notice that there's a little bit of an alpha issue. And you don't want that because you'll be using this entire image to undistort your camera footage. So you want to make sure that there are no issues when you bring in as a TIFF file in terms of the alpha channel. And how you're going to solve this is basically create a shuffle node and then set this as 1, and as you can see, that solves the alpha problem. Now you see, without the shuffle node, with the shuffle node, without the shuffle node, with the shuffle node, and this is how it looks like. And you're going to bring this out into PTGUI. So let's actually create a write node and export this as a TIFF file. Now I'm going to just set it on my desktop, make it easier. And I'll call this stmap tiff.tiff. Now before this, very important, save your file. Save it to wherever you want, but in this purpose, I'm going to save it onto my desktop. So when you create your SD map, just make sure that this data type is set to 16-bit. And everything else should be good, and you should be writing this out. Alright, and now you only need one frame, of course. And let's do that very quickly. There you go. So this is how you create your SD map to bring into PTGUI. Alright. Now that you have assuming that you've gone into PTGUI and actually get the undistortion values from PTGUI with the SD map, that you already have a file that's set up that looks like it has a rectilinear projection. Something like this. Now as you can see, it took a while for the file to load, and that's because when you export it from PTGUI, it tends to be a very heavy file, even though it's just one frame and a TIFF file. So what you want to do is you want to ideally kind of write this out as an EXR, although you don't have to, nothing changes if you do that. But for me, that's what I'll probably do. So I'm going to do that very quickly. Going back to my desktop and then creating stmap, exr, exr. So once again, when you read your file, just make sure you have set this to raw data. You always want to be able to bring in all the raw information from your stmap because it's very important in terms of where the distortion values are and the colors of this actual image. So while I have this set up, let's write this out as an exr file. And while it's writing, I'm going to clean up and group this, calling this stmap tiff to exr. As you can see, it took a little bit of a while just to write out this file. All right. So that aside, there's one last thing that we have to do before we proceed to bring in our footages. And let me just clean up the properties tab here. It's getting a little bit messy. So now I'm assuming that once you've gotten to this point, you have a center image frame that you've exported out from PTGUI. And basically it's the fisheye lens center image that looks something like this. So what this actually means is that the difference between these two, this rectilinear is basically for you to undistort your camera footage, and this image is what it's supposed to look like when you project it onto a sphere. So this is technically your piece of a lat long, and this is your undistortion to unwarp your camera lenses. So grab your JPEG file or read it or import it into your new comp. And we're going to do a quick camera overscan calibration test in this particular case. So let's create a quick mirror node and a sphere and then pipe this in. So make sure you set your mirror node to horizontal flop, and the reason for this is because when you wrap it around your sphere, it actually does the wrapping in an inverse way. So as you can see, without this, it's actually inverse. So you use the mirror to set it to the correct flipping. So in that case, let me actually just change this to 100 by 100 and 100. Let's make it bigger. So what you're going to do now is actually create a camera scanline node and a reformat. Now these three nodes will be your key pieces in terms of setting up the stitching later, and you'll see why as we go along. Alright, so pipe in your object into the sphere and then the camera into your, well, camera. So the first thing I'm going to do right now is set up this camera to be able to then overscan this image. Now what I mean by overscan is that when you look at this file, as it loads for a second. So one very important thing, it does get pretty heavy. So you might want to be saving occasionally because Nuke does tend to get does tend to crash if it gets too heavy, and stitching via Nuke it does get pretty heavy on the file. So just make sure you save your file, and let me explain what I mean. So now as you can see, this is what it looks like at this point, and you're not really seeing the whole image like this. So the purpose of the overscan is basically for you to be able to capture all four corners of your plate or this template right here, and that will be used for each of the other camera footages later. So let's do that right now. Alright, so in the projection tab of your camera node, focal length here is something we'll be adjusting. Now, you might be curious to know that this will actually be an expression that we'll use to calculate the focal length. And you'll be wondering, okay, so how am I supposed to find out the expression? Well, Google is a good friend of ours, and that's what you're going to do right now at this particular point. Let's actually do this right now. Let's search for focal length calculation nuke. And as you can see, the very first link itself brings us to the mathematical equation of how to calculate a focal length. And as you read here, focal length, blah, blah, blah. So we're going to use this right now. Now, of course, don't expect this to work because, you know, that is simply the equation and the formula, but you actually have to customize this to your nuke settings. So I believe H-app is H-aperture, so let's actually change that, H-aperture, and clean up the spaces here, although I don't think it matters. Now, FOV2. Okay, so you'll be wondering, what is this FOV2? Well, if you're more savvy in terms of actually creating your own customized tab, you can always create a tab to set the field of view settings. But at this point, we get this value directly from PTGUI. So let's actually do that right now and grab our value of the FOV from PTGUI. So I've opened up my PTGUI file, and as you can see right here, it really doesn't matter which file you open, whether you open the one with the ST map or the 6 images. But what you're trying to do is get the field of view information, and you can go into the image parameters and find this right here, 125.616. Now, if you're more tech savvy and you prefer to look at things through the text editor, you can also do this by going to the folder where your PTGUI file is at. Right click and edit with Notepad. And as you can see right here, this is the same value, your field of view. But me preferring the graphical user interface, I'll actually use that. So I'm going to plug in this value, 125.616 into FOV2 in my nuke file. And hit OK. And let the expression do itself. Now, you can see this looks very familiar. And the reason for this is because it's supposed to reflect the rectilinear understore that you've got from PTGUI. So that's good, now that we're seeing something familiar. All right, so next thing we're going to do right now is especially set the camera overscan. And now you probably understand what that means now. Basically, you want to be able to capture our entire image content without any edges being cropped off. So since this is going to be ideally, I suppose, a uniform scale, let's add an expression in order to allow that. So winscale.u, and that will actually make v follow u. So as you can see, use your discretional eye to eyeball this and in order to capture the full image into your canvas. Now that looks almost close enough. Just go a little bit further down. So make sure you have all 4 corners of your undistorted image. And let's clear the Properties tab and make sure you save your file occasionally. Now that you have that set up, it's 2K, this resolution right here. So what you want to do right now is basically to, well, make sure that you have enough resolution to work with this. And we're going to use the reformat node plugged into the background of the scanline render in order to do that. Now, opening up your reformat properties, we're going to change this to box. And we're going to really basically force the shape. Make it a better resolution. And how you can do that is basically create an expression right here. And allow this to read the camera's overscan so that you have a big resolution file to work with when you project this onto a sphere. So let's actually do that. Right, camera 1, which I believe is our camera right here. And then have it read the window scale. Now, because we're working with GoPro, which is 1920 by 1440, we want to multiply this by the width of the GoPro camera. And hit OK. And then same thing here. Let's just actually copy that expression. So we do that and replace that with 1440. Now as you can see, this is without, this is with. And it sort of crops off that extra black space that you saw earlier. So this is not only good for actually having a higher resolution image to project into your sphere, but also, to allow you to actually crop off things to ensure a 4:3 aspect ratio. As you can see, I can zoom in. There you go. Look at that change. Alright, so now that we have this one-time setup, let's call this camera overscan. We are actually ready to bring in our footages. Firstly though, I'm assuming that if you've gotten to this point, you already have your footages all synchronized, either using Video Stitch, PTGUI, or some other software like maybe Nuke. And if I'm not mistaken, you probably use a Flash or audio sync. Now, that's all fine and dandy, except the fact that you actually have to kind of work with EXR footages for this example, because MPEG-4s tend to be a severe lag on Nuke, and it's not really, it does get kind of clunky working with MPEG-4. So in this particular case, I'm going to explain how I got my footages and what you should probably do in order to continue with the next steps. So after you sync your footage, assuming whether you did it in Nuke or in Video Stitch, you bring in your sync frames and obviously time offset these. And then what you want to do is actually convert these into EXR files. Now here's where the explanation of that frame start and the frame range makes sense. So let me explain why I'm starting with 1001. As you all know, most visual effects studios use this frame number mainly for frame padding purposes, but also for animation and FX particles. But even though we're not using FX particles or animation, maybe not at this point right now, it's always good as a common practice to start at 1001 just to have frame padding. So right now, that's what you're going to do. We create a frame range and time offset so that you actually start at 1001 and then export these files as an EXR 16-bit. So remember, each of your camera footages has to be exported as an EXR file, which we get right here. So after you've done that, let's import all our camera footages. So I already have an import set up right here. As you can see, they're all EXRs and they all already have been synced. So what I do next is probably create a crop node for each of these to ensure that I'm only getting 1920 by 1440, as you can see right here. So with that ready and all set up, I'll be bringing in my ST map that was generated via TIFF. And we're going to use the center camera, which I believe is this camera, since we actually use the center camera to generate our ST map. Alright, so how this is done, very quickly, create an ST map node and plug the ST map into source. Very easy, right? Well, not exactly. As you can see, the ST map is extremely big. It's actually unnecessarily big, and our footage is only 1920 by 1440. So what you want to do is basically reformat that and crop this area in order to fit this image resolution. So let's do that via reformat node. And actually plug this in. Plug STMap in. And we're going to set this to box and resize type to none so we can actually see what we're looking at. Right now it is it is very small, so what you're going to do is basically adjust the size. Now, before that, as we know, this is a 4:3 footage. So to make our adjusting easier on us, we're going to actually have this kind of follow the aspect ratio of our footage. So as you know, right now, this would be box dash width and then multiply 0.75. Now why 0.75? Because 4:3 and then 100, assuming that the width is 100%, 3 of this would be 75%. So that would be giving our aspect ratio. As you can see, the box didn't change, just the resolution, similar to the GoPro camera. Alright, so now let's actually use our discretional eye. I'm assuming that's probably going to be bigger than that, to adjust this to fit the 4 corners of our ST map. So I'm just adjusting this to fit appropriately. Seeing that, you can see here. Make sure you don't crop any of your, not even a pixel, because you want to make sure you have all your undistortion values in here, and there you go. Alright, now, so assuming you've gotten to this point, you'll be wondering, my SC map's not really doing anything. Well, that's because you need to set the UV channels to RGB, and there you go. The next step is you're kind of ready to project this onto a sphere. However, as you can see, there's some alpha issues, but we'll address that later. Now, actually, let's create the project 3D node to really quickly set this up. Pipe this in, and then create a sphere. And we're gonna actually change the columns and rows to 100 by 100 and radius 100, just for good measure. So now the good thing about this is that you have a one-time camera setup, and the focal length and the window scan pretty much works the same for all cameras. And that's the good part. So all you basically need to do is, when you're recreating this camera, is actually plug in your PT-GUI values of the yaw, pitch, and roll into the rotation of the camera, and that basically creates your camera for each of these cameras. So let's just do that very quickly. Now, just make sure that you have everything all the same from the one-time camera setup of the overscan. And then we're going to actually copy the PT-GUI values into these camera settings. So what we're going to do right now, yaw for Y, pitch for X, and roll for Z. So you're going to actually copy these values into the camera. So let's do that for the center camera here. I'm just going to keep calling this center camera and paste a yaw and a pitch in the X. So in order to see what this looks like, let's actually create a scanline render node and set this projection mode to spherical. Now, as you can see, we'll fix the alpha values later. Oh, and just in case you're wondering, make sure that your comp, if you hit S, is set to 4K by 2K or 4K UHD. Now, I believe I might have missed this step earlier, so I'm just mentioning it again. If you're wondering why your comp looks squished if it was initially this, then that's the reason why. It's because you need to set your full size format as 4K UHD in order to export this to whatever size that you want in whatever device, whether you want to see it on the Gear or the Oculus Rift or whatever. So there you go, just making sure, and let's clear the properties tab, make it clean. Now let's see what this looks like in 3D. Now as you see, this is your center camera right here. I'm just going to keep calling this center camera, and you can see the alpha is giving us a little bit of an issue. Now, before we get to fixing the alpha, it is important to note that in PT-GUI, they also gave you a horizontal and vertical shift value. So if I remove these, and if you could watch this image right here, it moved ever so slightly. And we basically want to recreate that as well because it is important and crucial to the stitching of the final image. And if you hit Ctrl E, this is what the final image looks like. So if you actually don't have these values, there is potential chance that it will actually affect your entire stitch. So you don't want that, and make sure not to move that as well. So let's do that very quickly and actually copy these over via a transform node. So create a transform node, hit T, and plug it in between your ST map and your crop. So we'll actually plug in those values. And there you go. Now, as you can see, it didn't really actually fix the alpha, but for each of these cameras as well, based on the different values given by the horizontal and vertical shifts, it will actually affect, give you a different variety of results. Now, if you hit A, you can see that there's a little bit of a wonkiness going on here. And that can be fixed and addressed either at this phase or later when you actually mask these areas out. It's not an issue because what we're simply doing is getting rid of the unnecessary alpha that was captured in as an opaque image, and we have enough overlap in order to compensate those areas later when we mask it out. So right now, this is what we have. And we're trying to use a reference image. Now, as we know, it is always very important to go back to your PTGUI file and use it as a reference. So if you have not already, export this as a JPEG and set optimum size of the full entire stitch in order for you to use as a reference. So I already have that set up, so I'm actually gonna just bring it in. And it's a JPEG file. So it seems like it's slightly off a bit. And you might be wondering, okay, so I applied those values. What next? Well, firstly, something that I did not mention, always make sure that your center point is set to the center of each of your cameras. And we're going to do that by setting 1920 divided by 2 and then 1440 divided by 2. And then still, something interesting about PTGUI is that when you bring in those values, it is undefined which direction the x-axis is. So there is a chance that a positive direction might actually be what Nuke is reading instead of what PTGUI needs. Now, this is where you actually have to do a little bit of trial and error to experiment with this because you won't really know until you actually see the final result. So let's do that very quickly. We're trying to basically match these two. So if we hit W, and actually let's reformat this so we have the same view resolution to that size of the composition. And that should actually look much better. Yes. So, all right. So as you can see, there's a slight shift. And this is not what we want. And it might be due to the translation values here. So what happens if we actually change this to a positive? Oh, and look at that. An exact lineup. Now, this is already trial and error, and you won't know until you actually try. So it really all boils down to experimenting at this point because, like I said, you won't know whether the X direction is actually positive in PTGUI or negative in Nuke and how it reads those values. So always play around with adding a minus or making it a positive in order to get the result that you want before you change these values, before you actually adjust the individual numbers. So now that that actually worked, let's hit W to get rid of that, and we have this as a reference. Let's move this aside. And you can see that shift actually removed the alpha channel issue for you. So it's actually fixed. However, there are cases where certain other cameras will have that alpha channel issue, and what you can do to address that is basically create a copy node and a pre-mount node, and there goes. Alright, so that is basically our quick tutorial on how to create an ST map, use the undistortion values on the ST map to then generate a spherical projection onto a sphere. And in the next tutorial, we'll actually proceed to continue with our color correction and then final stitching in VR, and then cleaning up according to the comp in terms of removing any seams and stuff like that. So yes, looking forward to the next step.